All right, today we're going to be talking about Chapter 11, Lesson 2. This is triangles and the Pythagorean Theorem. So first of all, we're going to be talking about triangles. Now, triangles, they're defined by three angles, which is why it's called a triangle. And if you only have three angles, that means you also have three sides. So the cool thing is about triangles is if you add up the degrees of each triangle, so if I were to say x and y and z, those three angles, they will always add up to 180 degrees. Always. So if I'm missing one of the angles, I can use the other two to solve a simple equation. So let's use that in example 1. Find the value of x, which is right here, in triangle PQR. So again, if I add them all up, I get 180 degrees. So let's add them all up. 33 degrees plus 100 degrees plus x is 180 degrees. Combine like terms, 33 plus 100 is 133 degrees. I now have a simple one-step equation. Subtract 133 from both sides, and I get x is equal to 47 degrees. Nice and easy. Example 2, however, is a little bit more difficult. It says if the angles of a triangle have a ratio of 2 to 3 to 5, find the angles of the triangle. So what I'm going to do is instead of leaving it as 2 to 3 to 5, I'm going to say that 2 is 2x, 3 is 3x, and 5 is 5x, because I know that this would then have a ratio of 2 to 3 to 5. Combine like terms, 2x and 3x and 5x is 10x. Divide by 10, you get x equals 18. However, it says find the angles of the triangle. So the first angle would be 2 times 18, which is 36. Next one would be 3 times 18, which is 54 degrees. And the last one would be 5 times 18, which is going to be 90 degrees. And this is the overall answer to this question. Continuing to talk about triangles now, let's find exterior angles. So there's a special rule when it comes to finding out the exterior angle of a triangle. So this here is an exterior angle because it's outside of the triangle. And we can say that x is equal to a plus b. Now, how we can show that this is actually true is because a and b and c all form a triangle, so they equal 180 degrees. And I know that c and x, they form a straight angle. They also equal 180 degrees. So I'd have a plus b plus c is equal to c plus x. Because they both equal 180 degrees, that means they are equal to each other. If I subtract c from both sides, cancels out here and here, so I'm left with just a plus b equals x. So let's use this information in example 3. It says, in the figure below, angle 4, that's this one right here, this is 135 degrees. Find angle 2. So what I can do, I can actually do this in two different ways. I'm going to use the equation, though, that we came up with on top. So angle 4 is equal to angle 2 plus the 90 degree angle, which is right here. Angle 4 is 135 degrees. Angle 2 is what I'm looking for, and I have 90 degrees. Subtract 90 from both sides, and I get 45 degrees is what angle 2 is. The other way I could have done it, I could have found angle 1 first, because 1 and 4, those two angles form a straight angle. That would have given me 45 degrees. And 90 plus 45 plus this angle is 180, which would have still gotten me 45 degrees. So that's finding angles of a triangle. Now let's look at how to classify triangles. So we have two different ways that we can classify triangles, with angles and with sides. So if we look at the sides or at angles of a triangle, we have acute, obtuse, and right. An acute triangle would look something like this, where all three angles are acute. An obtuse triangle would look something like this, where I have one obtuse angle. And in fact, that angle would be right here. And then a right triangle would have one right angle. If we look at sides now, scaling triangles, all sides are different lengths, which means that there aren't any congruent side lengths. An isosceles triangle has two sides that are congruent. Remember, congruent means equal. And an equilateral triangle would look something like this, and that means all sides are equal or congruent. So let's utilize that information to figure out how to classify triangles in example 4 for letters A and B. So, letter A, I have a 38, a 36, and a 106. So already we know that this is obtuse. Because all angles are different, that means all the sides are different. So this would be an obtuse scaling triangle. And in letter B, it has a right angle, so this is a right triangle. These dash marks here mean that they are the same length, which means that this is a right isosceles triangle. And last but not least, dealing with triangles, we have the Pythagorean theorem. So Pythagorean theorem helps us understand how to find a missing side length on a triangle. And the formula for this is a squared plus b squared equals c squared. What that means is if I make a square on this side, the area of this square would be a squared because this side length is a. If I do the same thing here, make a square on this side, this area would be b squared because the side length is b. And what this theorem says is if I add the areas of these two squares, I get the area of this square. So let's look at example 5. Find the missing part. So always write down the formula. A and B are the lengths of the leg, so these are leg lengths. And C is the hypotenuse. And the hypotenuse is the longest side. So A and B are the leg lengths, which would be 5 and 12. So 5 squared plus 12 squared equals C squared. Recall that when I square a number, that means it's 5 times itself. So 5 times 5 would be 25. 12 times 12 is 144. And then I get C squared. Combined like terms, 25 and 144 is 169. Now, this does not mean to divide by 2. This means I have to take the square root of it. If I remember from my calculator, to find the square root, looking at the calculator here, what I would do, over here, we have this x squared button. if you look just above it, there's a little yellow radical sign. To get to the radical sign, or the yellow part of this, you have to hit the second button. So if you hit second and then x squared, on your calculator, a little radical sign will show up. You then type in the number, so 169, and then close the parentheses. Once you hit enter, you'll get an answer of 13. And that is what c squared is. So c equals 13. You should also recall that a 169 is a perfect square. And now let's look at example 6. Same exact process. The only difference now is I'm still going to write down the formula, but I know the hypotenuse now. So I'm going to do 4 squared plus b squared is what I'm looking for, equals 5 squared. Most common mistake here is students will go 4 and 5 in A and B. 5 is the longest side. It's the hypotenuse, so it needs to go in place of C, which is why you should always write down the formula at the very beginning of the problem. So 4 squared is 16. Leave b squared all by itself, and 5 squared is 25. Get b squared all by itself, so subtract 16 from both sides. I get b squared equals 9. I'm hoping the majority of us understand that 9 is a perfect square. But again, on your calculator, you would hit second, the x squared button, and then I'll get you a radical sign. Type in 9 and close the parenthesis, hit equals, and your answer will be 3. And I'm hoping that the majority of us still remember that b, this part here, 9 is a perfect square. Should have known that it is 3. All right, this is the end of lesson 2. If you have any questions, please let me know.